Here are a bunch of, my wife came yesterday class and she walked around and one of the things that she picked up on that I haven't maybe wishful thinking picked up on is how many people don't actually know the fundamental equations of the class. My volume is too low. Let's turn this up. Many of y'all have not actually learned the vocab, if you will, of the what? This is Spanish and y'all don't know the words. Okay. So I am going to challenge you to learn the vocab. These are not all of the skills that you need. Putting together the puzzle pieces, if there's more than one part, putting together the puzzle pieces is the meat of it. But if you don't know the words, if you don't know the core equations and definitions, how can you understand how to put them together? I'm going to do these. I'm sick and tired of the Google form and I'm not going to scan through everything. Incidentally, that means that if you're completely checked out, just get out of here. You're getting 100% for today. If you're not going to learn, go. But here's my, no prejudice. You can go. Everyone gets 100. But here are a whole bunch of questions designed to help you practice and check and see if you know stuff. Don't talk to each other till you do the problems. Don't use your whole notes, the internet, or whatever. Do use the equation sheet that you probably should, I hope, have been developing over the course of the semester. In particular, the equation sheet for the first exam should be everything you need to do all of these problems except for the spring force problem. Okay. If you take this and see if you can do these problems as if it's an exam, you'll know exactly how well you're going to do. I will then explain the things, and we'll talk about the core equations, but anyway, that's enough talking. For these three questions, I think this should take you 5 minutes. If you know the equations, it takes about 15 seconds. If you don't know the equations, I'm going to let you stew and suffer for a little bit. Okay, as I said, shh, 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 until you have done your best attempt, no talkie. When you have done it, then turn to your neighbor and discuss. Yeah. Yep, x equals negative 25 meters is the final. Ready, set, go. Hey, if you're not going to engage, go. Hi. If you don't follow instructions, you got full participation points. Just get out of here. Come on. If you're not going to follow instructions, get out of here. Come on. No? Well, if you're going to be here, do what I say. Nah, Tala. Everyone gets 100. You can put it in if you want. I'll keep an eye on it. Or if you have questions, as always. I forgot one of the original points. Whatever, as I promised, I'll give you 100 points for the participation. Today, I would like you to focus on learning. Actually, do put it in the Google form so I can track when people are done. If half the class isn't done, then I won't move on. So yeah, put this in A, B, and you'll never believe this, put that one in C. Well, that's 5 minutes, but I've only got 40 responses. Everyone hit enter when you're done, yeah? I'll give it another minute or two, and then we're moving on. Okay, let's do it. What is the defining equation for displacement? Final position minus initial position. Final minus initial. Not initial minus final. And not initial plus final. Any delta will be final value of whatever minus initial value. Half you got the sign wrong, which says that memorization is not, as I may have mentioned before, memorization is maybe not sufficient, and being able to think about what it means is helpful. I challenge you this: if I start with $0 in my bank account and I end with $100 in my bank account, is that a positive or a negative change? If I start with 0 and I end with 100, I hope you agree that my change is positive. If I plug in final is 100 minus initial is 0, do I get a positive or negative number? Positive number. Are you sure? You're positive. If you get the equation backwards and say initial minus final, make up a silly example for yourself like this, starting from 0 and ending at 100. Does it make sense that your bank account has gone up by negative 100? No, no, that doesn't make you sensey. Also, in displacement, the way that I interpreted this for you again and again is leftward motion, negative displacement. Rightward motion, positive displacement. Am I going from 120 to negative 25? Is that leftward or rightward? Quite far leftward. So I plug into les formulas and say final minus initial equals negative 145 meters. If traveling that 145 meters in the negative direction takes 20 seconds, find the average velocity. Well, what's average velocity's equation? Delta x over delta t, displacement per how long it took to affect that displacement. So I can just take that equation and plug in average velocity here is the displacement divided by the time it took to affect that displacement. Negative 7.25, 7.25, negative 7.3 meters per second. Negative. Going leftward. Leftward velocity, leftward displacement, negative. Okay, now I was imagining if you're moving steadily at 7.3 meters per second leftward, you get negative 145 meters displacement. What if you're starting from rest? Well, another very useful equation connecting these things is if I've got an initial and a final velocity, I could just find my average velocity. What's an average of two numbers? Add them together and divide by 2, not subtract them. Subtracting is delta, subtracting is difference, subtracting is change. Average does not depend on the difference between the numbers. Watch out. Okay, so if I start from 0 and I end it, if I want to know what I end at, find the final velocity, I could express this as 0 plus VF over dose times, times, what's the time interval I've got? 20 seconds. I claim that it better darn well equal the same displacement as original. Solva, let's see, 20 over 2 is 10. 145 over 10 is 14.5. Oh, don't drop the minus sign. I claim this gives me negative 14, roughly. Not 14 meters per second, 14.5 meters per second. It hurts me to write 3 significant figures when I'm just giving you very rough values like this. If you plugged in and got negative 14.5 from your calculator, that's the same answer. Okay, so I want to point out 14.5 rounds to 15. I'm smart. I want to point something out. If you start from rest and have an average of 7 point something, does it make sense that your final is twice your average? Going from 0 to twice a number averages to the original number? Okay, so if you start from 0 miles an hour and end up at 60 miles an hour, what's your average? 30 miles an hour, right? If you start at 0 miles an hour and average 90 miles an hour, what must have your final been? Oh, it's be really fast. If you start at 0 and average 90, what must your final have been? I think 180. Hmm? Okay, so you didn't actually have to do the whole problem this whole way. You could simply reason, if I start from 0 and I get the same distance in the same time, I must have ended up at twice as much if I want to average out to the same. If that doesn't make sense to you, you may freely ignore it. That's an alternate way to think about it. But one way that is not legal to think about it is to say that my final velocity is my total velocity, is my same velocity, is negative 7.3 meters per second done, because this is assuming that you're moving steadily. If you start from rest, you're changing your velocity. I mean, if you're going anywhere. If you're changing your velocity, you have to be, if you're changing your velocity, you have to have, if you're changing your velocity, you have to have a different initial from final. You can't just use distance equals velocity times time. There are many different velocities. Okay, so we have used these three examples to check on if you know these three formulas. If you don't know one of these, if you don't know one of these, I strongly suggest you learn it. There aren't that many foundational formulas. Everything that we're doing is built up from, I think, 20 formulas in the whole semester. If you know those, everything gets easier. If you don't memorize 20 words, if you can't learn 20 words of a foreign language class, well, if you don't learn 20 words, you're screwed in a language class. Here I'm asking you to learn 20 words, and if you can't learn those 20 words, you must at least know where to look them up. If you don't know that there is a connection between displacement and velocity and time, well, then you're really screwed and your equation sheet won't help you. You can make the prettiest equation sheet ever, but if you don't know that it's a thing to look up, yeah, that doesn't help you. So if you get an equation wrong, if you try to memorize it and don't get it quite right, you're free to check yourself on your equation sheet. But again, do not just think that having the prettiest equation sheet in the world is going to solve your problems if you don't know at least where to look. Okay, well, let's do three more problems that are going to lead to those three more equations, yeah? Well, here's two more that'll lead to two others. One of them is a two-part, a two-way. Okay, what do I think about another 5 minutes? Where does that go? And this will be, not astonishingly perhaps, what is it, D, E, and F. Why is my pen? Why is my pen? Note here I say in two different ways. I'll put one of them in E and one of them in F. State the equation that you're using, you know? It's the same answer either way. Hey, where's that go? Also, they're talking too much. Y'all are talking too little. They were talking too much at the beginning. That's why I verbally smacked them down. But once y'all have tried it, you should check with your neighbor. Okay. 30% have an answer. 70% of the class have not even answered the first part. We did this for a month, my dudes. Let me strongly encourage you. Don't forget stuff. Review stuff. Put it back in your memory. Revisit it. We've gotten so much harder problems since the beginning of the semester. What is the meaning of acceleration? What is the defining equation for acceleration? And why is my pen not working? Oh, thank God, it was just unscrewed. Acceleration is defined as the rate at which velocity changes. So if I know the acceleration and I know the time difference, what can I find? A times delta t equals what? What does 20 meters per second tell you? It tells you your speedometer has changed by 20 meters per second. 20, in other words, we could write V final minus V initial equals 20 meters per second. And I gave you a V initial. Solving this brutal equation, I can deduce, if my algebra is not incorrect, that my final velocity is 30 meters per second. Question. Okay, so all this is, if I've got velocity, time, acceleration information, I just connect those. Those are what the pieces of the definition of acceleration. Just plug in. Find the displacement and oh, and I am keeping a little I'm keeping a little what? I'm keeping a little person trapped in my basement. No, sorry. Keeping a little cheat sheet up here at the top. Thank you. You all get A's, by the way. Two different ways to find. Oh, I'll do three. Merry Christmas. I'll do three different ways to find displacement. I already have one equation for displacement. Displacement equals average velocity times time interval. I just found the final time. What is that? Initial velocity was 10. Final velocity is 30. The average of 10 and 30 is 220. 220 times 4 meters per second squared times 5 seconds. Plugging in the numbers that I gave above. 20 times 5 also goes by the name of 100 meters. Okay, that's one way to do it. Great. Here's another way to do it. Another equation that we hopefully can dust off from our memory banks is V initial t plus half a t squared. All I got to do is plug in 10 times 5 plus 1/2 times 4 times 5 squared goes by the name of 25. That is to say 50 plus, let's say, 4 over 2 is 2. 2 times 25 is another 50. Oh my God, it's the same answer. It's like physics is internally consistent or something. Oi? And a third way of doing it. V final squared equals V initial squared plus 2a delta x. Well, if I plug in, what is my final velocity? What is my initial velocity? What is my given acceleration? 900 minus 8, well, 100 is 800. So I get the first step, 800 equals 2 times 4 is 8 delta x. Again, delta x equals, shockingly, 100 meters. I want to emphasize that you don't have to know all of the equations. If you know a core set of them, you can figure out an alternate way to do it. Look, there are 3 individual ways to do this problem. If you forget one equation, you can do a 2-step process and recover anything. Let's see, this equation did just in terms that were originally given, right? First and the third equation depended on already having V final. If you forget this equation, you would have to do this sucker in 2 steps. First, find V final, the missing puzzle piece, like this, and then apply one of the 2 equations you do know. This is the same way in lots of areas of physics. If you forget something from energy land, you may be able to solve it with force methods or vice versa. I don't care what you do. Show me you've learned some physics. I don't care the method that you use to get it there. Okay, so 2 other equations in terms of velocity, initial velocity, acceleration, and time. Okay. Oh, and yes, and v final squared equals v initial squared plus 2a delta x. It's good. It's good. Do you remember these? Having seen these before? Having tangled with these? Great. Okay, let's do the reverse direction for this half. Can you state the defining equations first? And then the second pass will state them. I note here. Oh, no, wait. I have to ask you. I have forgotten because I have a great memory, like a steel bear trap. Did I say Fe for elastic force, or did I say Fs for spring force? When we talked about springs, did I say Fe or Fs? It's in your note. I said Fs? Oh, thank God. That's the term I use, then I'll use the same term. Okay, anyway, what? These are sort of know it or you don't. 3 minutes for this. Do it yourself, charge your neighbor. And what'll these be? G on? Gesundheit. Okay. There's more than one way to write Newton's second law. There's one. Weight force. Notice I specified vector, put the vector arrow on top. The direction is downward, the magnitude is mg. If you know that weight is downward and that you don't include, if you don't forget to include that, you can just know mg magnitude direction downward separately. Spring force negative k times change in length of the spring. Kinetic friction force. This one's the easy one, mu kn. The static friction maximum value is mu Sn. Note, static friction is not always its maximum possible value. Okay, now let's apply these. Can you see that? Yeah, those are uncovered. LMNO? No, LMN. You can round, by the way. Whenever I'm doing this in lecture, I'm going to do it in my head. I'm going to round. And I'm going to call times up. What are the fundamental formulas here? Well, for the very first one, okay, so if I've got 5 and 15 newtons, 15 and negative 5 newtons, how do I find F net? What does net even mean? Add them together and get the total. 5 and negative 15 and negative 5 add to 10. Total is 10 newtons. 10 newtons is F, 8 is M. .25, 1.3 meters per second squared. Actually, with the number of sig figs I gave you, it should just be 1, but screw that. I'm not asking you to track it. Okay, second one, weight formula. Weight formula that we just gave above. Weight magnitude equals mg. I was ambiguous here. I would accept positive or negative. I didn't say what is the weight, the magnitude. I didn't say what is the weight vector. So I'm not going to give you a question where I ask you to guess by an ambiguous expression the right or wrong answer. There will be a clearly correct or incorrect. If I want the vector, I will tell you the vector with direction. 10 kilograms times 9.8, 10, 100 newtons. If you put negative 100 newtons, again, I would fully accept that's fine. 98 equals 100, sure. Hey, what's the formula? What we just wrote above is F equals negative K delta X. Which direction is the force, by the way? It's supporting the dog, right? And which direction is the spring displacing? Yeah, I'd say that's the negative direction. So if I plug in, well, the weight must be supported by the weight of the dog is being supported by the spring. So I think that the spring force is equal to the weight force. And the stretch of the spring is negative 0.05. Hey, what's a negative negative? A positive. Those negative signs cancel out. K is never a negative number. Wait, 2,000 or 20,000? 100 divided by 5 would be 20, 200, yeah. Excuse me. If you carried through the 9.8, it would be 1,960 newtons per meter. Again, I will allow you to do that, and I will say that I will never give an answer that you can't deduce which one I'm using. Okay, that only about 25% of the class answered, and we had just given the formulas, so methinks that something in here is breaking you all. Again, we just had the formulas and plugging them in, only a quarter of y'all answered. So let me ask this. Google question O is talk to your neighbor for a minute, then tell me where are these parts confusing? What can I help you remind you about this foundational stuff to make some more sense of it? Google question O, give me some feedback. Where's the stuck? As usual, if you have nothing to say, then don't say anything at all. Okay, I've got some questions, and let me encourage you, even if you didn't ask an individual question, you can learn from other people's curiosity. Question uno. Question uno was, why did we use 100 in place of FS here? Well, what did I say? If the dog stands on it, if the dog is standing on the spring, we just found the dog's weight. Gravity is pulling down with 100 newtons. How much was the spring probably pushing up with? I'm assuming the dog is just standing there. I didn't say anything about any other forces acting on the dog. The dog's owner isn't pushing on the dog. Didn't say anything about that. So I would assume, given this question on a test, that weight force and spring force are in balance. So I assume that the spring force is equal to the weight force in this problem. Not too confusing, just rusty. Okay, that's okay. When force is positive or negative when it comes to the spring constant equation, well, the spring occasion, force equals negative kx says that the force is in the opposite direction as delta x. If delta x is compressing, if the spring is smaller than it wants to be, the force is in the expandy direction. The force is in the opposite sign of the compression or expansion. If you expand a spring, if its length, if its delta x is a positive number, the direction of the force is in the opposite direction, is in the negative direction. That's how I internalize the negative sign in negative k delta x. Usually, when we've been doing these problems, I have given you enough information. I have told you the spring is stretched and you're dangling something from the spring. Well, of course, the direction the spring is pulling is up. And we've just jumped to the magnitude of that upward force is kx, where x is the amount of stretch, the distance stretched. If you know the direction of the force, then you are free to use the magnitude and impose the direction plus or minus based on sanity. Okay. Question, busy taking notes. You don't post this stuff. I'm sorry. You're right. I will do my damnedest to remember to post these slides. I will point out that we do the same thing again and again, that we have reviewed this multiple times, and these are posted to YouTube. I'm not saying that I'm not wrong to post these, not post all of these slides, but in my own defense. Just rusty, okay, sure. Not having enough time to finish, okay, I could give a little longer, but again, many of these are sort of you know it or you don't. So I'm nervous if you're taking longer than 5 minutes to do 3 questions, you might very well run out of questions, run out of time on the final. I think it's worthwhile knowing if you're able to do it in the sort of time that you need to be able to do. Question, identifying what force is in different scenarios. What is F in various scenarios? Well, hint, if I talk about springs, use the spring equation. If I talk about weight, use the weight equation. If I use the kinetic friction coefficient symbol, that's a hint that you should use the kinetic friction equation. Now, in general, you're given a problem and not told specifically what to use. Yes, you have to think, all right, why am I slowing down? What is acting on me? There is a rough ground beneath me. It must be a friction force. That's not a matter of something I can give you you always use this when you see this word. You have to think about, why is my box slowing down as it slides across the ground? There must be friction. You have to visualize these things and think about think about what's actually going on instead of just looking for a keyword and bam, there's the answer. Can I calculate K by mg over delta x? That's exactly what we did. Lost when to plug in the correct numbers at the correct spot. Okay, well, I suggest that if you're not knowing when to plug in what to the given equation, then you don't know the equation letters. W stands for weight, M stands for mass, G stands for gravitational field. You need to rewatch these lectures, look at your notes, your course notes, read the book for God's sake. The individual letters always mean in any given context same thing. Question, so comment. If y equals negative x, does that mean that x is negative? If x is -1, then y equals 1. If x is 1, y equals -1. Just writing a negative sign in front of something doesn't mean that quantity is negative. There is no negative mass. Nothing has negative mass. But, as I said before, I said weight vector here. This symbol on top means tell me the direction as well. Yeah, that's the vector sign. So properly, if I'm saying tell me the direction and magnitude, that minus sign says the direction is in the negative or downward direction. It's not that m is negative, it's that weight is downward. I like it though. Good question. Why? Oh, and why did I use positive mg here? I wasn't specifically talking about the vector. I know that it's downward. I don't care about the directionality here, so I just wrote its magnitude. As I said, you will never get the answer wrong. I will never give you positive 100 and negative 100 and ask you to guess by the ambiguous expression, tell me the weight. I will always specify, tell me the weight vector, tell me the weight magnitude if it makes a difference. Good. For clarification, spring is compressed, displacement is negative. That's the convention. Why do we use μSN for the spring force? We don't. We don't use μSN for the spring force. μSN is the static friction force. Why do we use that? Because that's what's been discovered. That's the law. It's sort of like saying, why is the speed limit 60 miles an hour? Well, because it is. Yeah. Always. Yeah, I'm rounding. Whenever I do things in lecture, you are free to use your calculator. Since I don't want to be spending time here, you will never get it wrong on a test. As I said, yes, that is with more decimal places. If your answer rounds to what I'm doing in lecture in real time, you got it right. And on a test, as I just said again, let me repeat, on a test, it will never be ambiguous. You will not have to guess whether I meant to round or not. The answers will always be separated by enough that there will be an obviously closest best answer. Okay, moving on. The formulas, let's take a look at these formulas here for a second. Kinetic friction formula, kinetic friction formula. The value of the magnitude of kinetic friction is always mu kn, n is the normal force. Please do remember the direction of kinetic friction is not always in the opposite direction as the velocity. That's why I didn't indicate a vector sign on top of Fk. You have to think about the direction based on if there were no friction, which way would the object? Friction opposes that. Likewise with static friction, the direction of static friction is, if there were no friction, would the object be going off the left end or the right end of the pickup truck? Friction opposite that. So that's why I didn't write minus signs or direction arrows on top. I want to point out also, Fs is whatever it needs to be, up to its maximum breaking value. Its maximum breaking value is μSN. Do not, you will miss points if you just see a static friction coefficient and jump to the force is μSN. However, in this case, I am asking about an extremum case. Oh, that's a hint. Ready, set, go. And I can give, okay, let's see. What? I did 50 questions for 150 minutes. So that's 3 minutes a question on average. Some are faster, some are slower. But I'm going to give you 2 questions. Let's give you 6 minutes. This is the average amount of time that you'll have for an average question on the average final, well, on the final. Hint for the first part, no, I didn't tell you the normal force, but I do expect that you were able to find the normal force. Ditto for 2. My method. to the point of somebody who said, I don't know what to identify, what force is what, let me encourage you to think about this. If you're skating across ice and you're slowing down, is gravity slowing you? Is tension slowing you? Are you tied to a rope? Is the ground force upward slowing you? Is there a spring slowing you? What must be left? The only other force that we studied is friction. Oh, I mean, friction slowing things down as they move over a rough surface, that should maybe seem some kind of sense. So if I write down the kinetic friction formula, oh, look, that's something I want to know. Oh, but I don't know normal force. Well, what is normal force? Normal force of the ice supporting the skater had better damn well be equal to the weight force of the earth pulling down on the skater. If those aren't equal, the skater will fly up through the air or fall through the ice. So I think you should be able to deduce that in this circumstance, normal is equal to weight. Please remember, this is not always true. Do not write on your equation sheet n equals mg. That is not true. That will get you into trouble equationally. But if there are only two forces vertically, normal and weight, and there's no acceleration vertically, then normal and weight must be in balance. Okay, great, but we don't know Fk. I told you A. Acceleration versus the only force that is pushing on us. I tell you acceleration. In the context of a force problem, I would hope that you think of the first foundational law, F equals ma. Now, F does not always equal friction, but I mean, think about it. You're skating across a lake. Is there any other thing pushing you back or forward? Friction is the only force. If friction is the only force, then Fk equals Fnet, and I can write down Fnet equals ma. Oh, look, it turns out the mass cancels. You don't need the mass. Okay, so I get A equals mu kg. Mu k times g equals A. I can solve that algebraically by dividing by g. Mu k equals A divided by g. Acceleration, negative point, well, hold on a second. The magnitude of the acceleration is 0.5 meters per second squared. Of course, the direction of the force and the direction of the acceleration are in the same direction. I don't include a minus sign. It doesn't make sense to include a minus sign here. The direction of the acceleration and the force, if both one is negative, then the other is negative as well. What are the units of mu? Nada, nothing. It is a ratio of two forces. N is a force, F is a force. Force divided by force is unitless. We're almost out of time, so I'm going to go ahead and do this one. I'm sorry if you ran out of time for doing these. I see a 1,500 kilogram car going from 0 to 30 meters per second in 5 seconds. Oh, it just itches. It itches to say that acceleration is the rate at which velocity changes, which is to say 30 over 5 is 6 meters per second squared. Okay, so if I've got a 6 meter per second squared acceleration and a 1,500 kilogram car, oh, it stings, it burns. I want to do F net equals ma. 9,000-ish. Okay, so if I know the net force, wait, hold on. Okay, so let's read the problem. What is the minimum static friction coefficient? Well, static friction is not always equal to net force, but I think if you're revving to go, if you're in a car that's trying to accelerate, static friction is what is providing that force. Static friction is not always equal to mu Sn, but if in particular I'm talking about what is the limiting, what is the minimum, what is the threshold value to be able to provide this force, I think it only makes sense to say we are at the limit, mu Sn equals Net force. Oh, and what's N? Just like in the previous problem, it makes sense to apply N equals mg. Mg would be 15,000. I could solve from US, 9,000, 15,000 also goes by the name 0.6. This is not everything, but here's a starting point. And if you're going to put off this until the night before the final, you're really royally screwed. Now is the time to learn your vocab so that when you study the techniques that we've been practicing, you learn anything at all. It shouldn't make sense if you don't know the words of a language. The sentences of the language shouldn't make sense. So go learn your vocab and then study the techniques that we've been applying. And I think you'll see it's rather easier than it was perhaps the first time around. Hey, we are out of time. I'll stick around for questions. Au revoir. Au revoir.